Okay, let's go over the last quiz of the 6 weeks. Quiz 4, reciprocal functions. Um, so a reciprocal function, what is a reciprocal function? A reciprocal function is a function from rational expressions. It's just a fraction of a function that is a form of a fraction. It's actually this one. The most basic one is y is equal to 1 over x. Okay, this is the most simplest rational expression, and that is what is called the rational function. So what are some of the properties of the rational function? Well, first, let's actually start with number 2, because I want to go ahead and graph the parent function. So number 2 over here says graph -1 uh, over x plus 5 minus 6. So before I do that, whenever we do any of these without the calculator, what you want to do first is you want to refer back to the original one, the parent function. The parent function is, I'm going to do it in light color, f of x is equal to 1 over x. So what is 1 over x? What are the properties of 1 over x? Well, 1 over x has the asymptote of, has a vertical asymptote at x is equal to 0. So it's right here. Oops. Let me break it down. Make sure it's broken down. Okay. Why? Because if you plug in 0, you get undefined. So the graph is not allowed to cross this line. And it has a horizontal asymptote at y is equal to 0. So it's right here. And the reason there's a horizontal asymptote there is, think about it, the bigger x gets, 1 divided by a big number is really, 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 really tiny. So what's going to happen is that 1 divided by 1 is 1. It goes through 1, 1. And the bigger that it gets, the bigger x gets, this gets smaller and smaller and smaller. Now, if you divide by a small number, it actually gets bigger. So it looks just like that. So this is going to approach 0 here, and it's going to approach 0 there. And over here is going to behave the same way at -1, -1. Why did I use that color? I want to use orange. So it's going to go through here and going to get smaller, and it's going to go that way. And then -1 is going to go through here and going to go that way. So this is the parent function. This is of the reciprocal, 1 over x. Okay, now we have to know what these other numbers do. So what does the plus 5 do? This number is actually going to move it left and right. The plus 5 actually does the opposite of what you think. Instead of going to the right, is going to go to the left. This number right here is going to move it up and down. And this one behaves like you'd expect. Instead of going up, since it's negative, is going to go down. This negative is going to do what? This negative is actually going to flip it. What do I mean by flip? Right now, the parent function is at what quadrants? The quadrants are quadrant 1 and quadrant 3. This is quadrant 2 and this is quadrant 4. So if it's negative, it's actually going to flip and it's going to reflect over the x-axis, and it's going to reside in the second quadrant and the third quadrant. So let's get to moving. So x plus 5, this vertical asymptote is going to, well, everything's going to move to left. So the ones that are going to guide everything are going to be the asymptotes. If it moves to the left, that means this is going 1, 2, 3, 4, 5 over here. This is going to be my new vertical asymptote. If it moves down 6, then this asymptote is the one that's going to move, but everything moves. But this is the one 1, 2, 3, 4, 5, 6. This is the one that guides everything. So this is going to be right here. And now, is it going to be in quadrant 1 and 3 or 2 and 4? Since it flipped, its negative is going to be quadrants 2 and 4. So it's going to go something like that. Okay. And right there. And that is it. The blue one is my, the final one. The blue one is the graph for this equation right here. Okay, do you see that? The two asymptotes, this is the graph right there. Now, some things that are good to know is where the asymptotes are and the domain and range. This vertical asymptote moved, right? Now it's at x is equal to -5. This horizontal asymptote moved. Now the horizontal asymptote is where? Is at y is equal to -6, right? So now if I want to know the domain and range, the domain here, if you look at everything, all the x's from left to right, it covers everything except for this, right? See, it goes to the left all the way. It comes all the way to the asymptote, gets really close, goes in another direction, and it starts over again here, and it goes to the right. So this is actually all reals, except x does not equal to what? It doesn't touch the asymptote, which is -5. You see how it's related? The asymptote and the exclusion, the denominator, all that's the same thing. And then the what about the range? The range is going to be all reals again, except the asymptote that the range doesn't touch is going to be y does not touch -6. Why? Because this is the asymptote right here. How do we write this in interval notation? This is all reals, all the numbers except -5 means from -infinity to -5. Open, it doesn't include -5. Union with -5 to infinity. So all this means is that from -infinity to 5 doesn't, and then you also join from -5 to 0. It picks up at -5. What about the range? The range is from -infinity this time to what? To -6 with the union of -6 to infinity. Okay, so that's how that one looks. Now let's look at number 1. Why did I do that one first? Because this one says select the correct choice. Which one of these is true about 1 over x? So 1 over x is the parent function, right? We already know what that looks like. It looks like this. It has the vertical asymptote right here at 0 and horizontal at 0, and it's going to go like this, right? Oh, let me like that. So that is it. Okay, this is the parent function. This is what we're looking at. Let's see which ones are true. The domain is from -infinity to +infinity. What does that mean? It's all reals, all the numbers. Range is from -infinity to +infinity. So does it include everything? No, there's an asymptote. So this is not true. Okay, this is false. The domain is from -infinity to 0, and then from 0 to infinity. So from -infinity, from the left all the way to 0, okay, so you see how it comes to 0 and changes direction, and then it picks up to the right of 0 and goes towards infinity. Okay, yes, that sounds good. What about the range? The range is from -infinity to 0, so coming from the bottom, right, the range is up and down. From the bottom, from -infinity to 0, okay, it doesn't touch 0, but then it picks up on the other side towards infinity. So range is from -infinity to 0, 0 to infinity. Yep. That one also looks good. So it seems like the answer is B. That one's true. Let's keep going. The domain is from 0 to infinity. So all the positives? No. The range is all the positives? No. It's on both sides. So that's not true. Domain is -infinity to 0, all the negatives. So the domain and range are just the negative numbers? No, that's not true. It lies in quadrants 2 and 4. So let's remember the quadrants again. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This lies in quadrant 1 and 3. What would make it go to 2 and 4? Well, it was the negative that made it go to 2 and 4. So this is also not true. The answer here is B. Okay, so we've done 1 and 2. Let's look at number 3. Number 3, what is the equation of the vertical asymptote for the rational function? So the vertical asymptote comes from, let's back up. What does asymptote mean? Asymptote means whenever you graph it, this is an imaginary line that never gets crossed. The graph can come close, but it never touches it or never crosses it. So where does it come from? Well, think about 1 over x. Whenever we had 1 over x, I cannot divide by 0. So guess what? 0 was the vertical asymptote. Okay. The vertical asymptote comes from 0 because x cannot equal to 0. The vertical asymptote, in other words, comes from when the denominator is equal to 0. Denominator equals to 0. That is where the vertical asymptote is. So whenever this part right here is equal to 0, that'll be where my vertical asymptote is. But before we set the bottom equal to 0, let's see if anything cancels out, because if it cancels out, it's not a vertical asymptote. So we have an x plus 1 here at the top. The bottom, let's see if this is quadratic, so we might be able to factor it. What are the two factors of 2? 2 and 1. 2 plus 1 is 3. Okay, so my factors are x plus 2 times x plus 1. Look at that, x plus 1 goes away, so I have 1 over x plus 2 left over, right? So this is the reduced rational expression. So that means that the vertical asymptote only comes from when this is equal to 0, which means what? X cannot equal to -2. This means that the vertical asymptote is at the line x is equal to 2. Okay, so imagine if you were to graph it, there would be a vertical asymptote here at where? At 2. And that makes sense, right? 1 over x plus 2 moves it to the, oops, I'm sorry, at -2. -2, -2. So good. You see how we caught that by graphing it? We saw that this actually moves it to the left. So this is -2, and this vertical asymptote here is not there. It's at negative, oops, at -2. Okay, so the answer is what? A. Last one. This one, if y varies inversely as x and y is 90 when x is 35, find y when x is 50. So this is really simple. In algebra 1, we saw that direct variation was when y over x at the beginning is equal to y over x at the end. But that's not what we're doing. We're doing inverse variation, right? Varies inversely. So the way this one works is xy is equal to xy. Xy at the beginning is equal to xy at the end. Or just to separate them apart, x1, y1 is equal to x2, y2. So what is my first x and y? My first x and y is going to be 90 times 35, or 35 times 90 is going to equal to, so find y when x is 50, so it's going to be 50 times y. 35 times 90 is going to be 3150. So 3150 is equal to 50y. We solve for y by dividing by 50. So 3150 divided by 50 is 63, and that's my answer. What if it was a little bit different? What if instead of, it didn't give you this 50, what if it just wanted the model? What is the model? That would mean that we would have, we wouldn't know this 50. We would just have 35 times 90 is equal to x times y, right? So this would be 3150. 35 times 90 is 3150 is equal to x, y. Now a model, all it is like a formula. So what is the formula? The formula is just an equation where y is equal to something. It's like something I can plug into it. So if I were to solve for y, how do I get rid of this x, or how do I move it to the other side? I would have to divide it on both sides. And so this would be y is equal to 3150 over x. So this would be true if it just asked the model. So in this, the original problem, it did ask you to find out what happens if x is 50. So pretty much the model would be used. I could plug in 50 here, or whatever the x is. In this case, it is 63 would be your output. Okay, so that is the end of that.